Okay, for Math 8, we are working in Course 3. If you are in 7 Advanced, it would be Advanced 2. It's 2 different books, but it's the same lesson, same problem, same everything, just the title of the books. Math 7 Advanced is Advanced 2. Math 8, you are in Course 3. We are currently working on Lesson 1.1. Example 2, page 5. So let's get started. Yesterday, we were doing one-step equations with addition and subtraction. Today, we are doing one-step equations with multiplication and division. So let's start easy. 3x equals 18. Okie doke. Let's take a blast from the past. 3 times x is also 3 times x, is also 3 times x, is also 3 times x. All 4 of these show multiplication. So what we have here is 3 times x equals 18. Just like yesterday, we want to isolate the variable. We need to get that variable by itself. So to do that, we need to unattach it from this times 3. Well, the inverse of multiplication of times 3 is divided by 3. And when we're working in algebra, we like to show division as a fraction. So what I do to one side, I must do to the other because we want both sides to stay balanced. So if I'm dividing this side by 3, I must divide this side by 3. Well, 3 divided by 3 is 1. So I'm left with x equals 18 divided by 3 is 6. X equals 6. And I can always check my work to make sure. I'm saying that x is equal to 6. So 3 times 6, well, 3 times 6 is 18. So this is a true statement. It checks. Yay. Okay, so this is how we do it when we're using whole numbers. And we do the same exact thing when we're using decimals. This problem is set up just like this one. I need to isolate this variable, which means I need to get rid of this times 9/100. So I'm going to divide by 9/100. And yes, you can mix fractions and decimals. We can do that. Okay? What I do to one side of the problem, I must do to the other side of the problem. So we need to divide this side by 9/100 as well. Now at this point, if you want to use a calculator, you are more than welcome to use a calculator. So 9/100 and divided by 9/100 is 1. We are left with x equals 1 8/10 divided by 9/100. If you were to put that into a calculator, you would see that it equals 20. So in this case, x equals 20. Okay, so here we have it with a whole number. Here we've done it with a decimal. Let's see what happens when we use a symbol. Okay, in this case, our variable is x. Pi is a symbol. It is not a variable. Pi is a very specific number, and this is the symbol for pi. It is not a variable. So we're going to treat this just like we would a number. I want to isolate x, which means I need to get rid of this times pi. So I'm going to divide by pi. And what I do to one side, I must do to the other. So when we look at this, my pi's cancel. Pi divided by pi is 1. So they cancel. And I am left with x equals, oh, would you look at this side? Pi cancels pi. Pi divided by pi is 1. Okay? And 1 times 3 is 3. So x equals 3. Not too shabby. Give me a thumbs up when I can turn the page. Okay, I've got some thumbs up. Hey, Justin, can you give me proof of life? That's a very nice hood, but I'd like to see that you're awake. Thank you. Okay. So let's take a look. Those problems weren't too bad. Those are all multiplication, and we're using division as the inverse to get rid of that multiplication. But sometimes we have problems like this. X divided by 7 equals 2. X divided by 7 equals 2. Well, I still need to isolate my variable. And to do that, I need to get rid of this divided by 7. Well, how do we get rid of divided by 7? We multiply this whole thing by 7. And if it helps you to keep things straight, you can multiply by 7, or you can multiply by 7 over 1. Either is fine. They are the same number. What I do to one side, I must do to the other. So if I multiply this side by 7, I must multiply this side by 7. Okay, now let's take a look. 7 divided by 7 is 1. They cancel. X divided by 1 is x. It is itself. And now this is just multiplication. If I want to, I can put this 2 over a 1 to make it easier. 2 times 7 is 14. 1 times 1 is 1. Or we could just say 2 times 7 is 14. Okay, that's not too bad. I see it. I'm getting it. But not all division problems look that way. Sometimes they look like this. 1/3 times x equals 8. 1/3 times x equals 8. Man, I don't know about this stuff. I do know I need to isolate my variable. But how am I going to get rid of this times 1/3? Well, how about if we multiply by the reciprocal? If I multiply this by 3, it cancels that fraction. And what I do to one side, I must do to the other. So 3 divided by 3 is 1. They cancel. And 1x is x. Now, if it helps you, you can put this over a 1, and you can see that those 1's cancel. And I'm left with x. Now here, it's a basic multiplication problem. 8 times 3, 24. Yay! Let's see. Okay, we've got 2 more to work through. Let's build on what we've got. Okay, 1/3 x equals 8. This next problem is set up exactly the same. -3/4 x equals -2. This problem is set up exactly the same as this problem. We have a fraction times our variable equals a whole number. A fraction times a variable equals our whole number. The only difference is we now have integers. So in this case, I still need to isolate my variable. And to do that, I'm going to multiply this by the reciprocal. And what I do to one side, I must do to the other. Okay. So I have a negative times a negative. That becomes a positive. Yay. 4 divided by 4 is 1. And 3 divided by 3 is 1. And you'll see I'm left with x. Now, a negative times a negative is a positive. 2 times 4 is 8. And if I need to, just to keep it straight in my head, I can put that 2 over a 1. And 1 times 3 is 3. So my answer is positive 8/3. Now you can leave this as an improper fraction because as we get further along in algebra, you will find that sometimes, more often than not, it's easier to work with an improper fraction than it is a mixed number. However, if you want the practice, you can turn it into a mixed number. Both of these are correct. Okay, let's take this one step further. 3/2 equals -9/10 x. Okay, so I say I have a fraction times my variable, but instead of equaling a whole number, it equals a fraction. Okay, that's not too bad. I think I can handle that. I also have a positive number and a negative number. I need to pay attention to my signs. Okay. I still need to isolate my variable. And to do that, I'm going to multiply this by -10/9. And what I do to one side, I must do to the other. Okay, now it just looks like simple fractions, basically. A negative times a negative is positive. 9 divided by 9 cancels, and 10 divided by 10 cancels. And I'm left with x all by his lonesome. He's very happy about this. He likes to be isolated. Now I have -10 times 3, -30. 9 times 2, 18. Okay, technically our answer is -30/18. However, this is a very ugly number to work with. I would not want to work with this number. It's a very ugly number. I know I can reduce this by 6. So I have a negative and a positive. My sign stays the same. 30 divided by 6 is 5. 18 divided by 6 is 3. This is a much nicer number to work with. Especially later on in algebra, when we have more steps and more numbers, I would much rather work with -5/3 than I would -30/18.